on capetalk.co.za,
on the app,
on DSTV channel 885,
and across the city on 567 AM.
Join the conversation.
This is Cape Talk.
This is Cape Talk.
It's that time of a Friday morning. We answer your science and natural history related questions with the good doctor, Dr. Chris Smith, the naked scientist, twice in a week. I'm a very lucky boy this week, Chris. You were in the chair with us on Monday. Get to chat to you again. I hope you've been well.
It's my lucky week as well as your lucky week. And do we still have any listeners? Twice in a week, like risk of overdose.
Well, we have some people lined up, so we go straight to the phone line. Simon in Brackenfell, good morning. Hope you are well.
Good morning. How are you, Lester?
I'm well. Dr. Chris is
Chris.
listening.
I work with hardwood with a sculpture, and my chainsaw blade doesn't get blunt. But I work with the same chainsaw on polystyrene and soft wood like palm trees, that kind of wood, soft wood. And the blade just gets blunt. I wonder why that is.
Simon, really appreciate it. And what I want to say about Simon, Chris, is he's a scientist himself. He's using observation and testing theories as he goes. So has that always been a trait of yours, Simon, to use observation to try and find an hypothesis, and then you start testing and whether your hypothesis is true, is correct?
Yeah, I love solving mysteries and figuring out how things work.
Well, your response, Chris?
You'll have to solve this one for me because I'm slightly bemused by that. The polystyrene, especially for people who, everyone knows what a chainsaw sounds like and looks like, but many people probably don't realise how exactly they work. The chain, which goes around a guide on the saw, has a series of blades which are angled, and they're at about 15 to 17 degrees, depending upon what the saws you've got, and they are a cross angle across the direction of travel of the blade. Some point in one direction, then the next one points in the other direction to make sure they actually cut uniformly. And as the blade runs around the guide, it's of course dragging these sharp knife edges across the surface you're trying to cut, and so it's taking small bits off, rather like you chiselling through a piece of wood. It's taking small bits off with each blade, and because there are hundreds of cuts every second going round, it's effectively shaving off lots of bits a blade's width wide every second, and that's how it cuts through the wood. So the harder the wood is, the more work that the tool has got to do, because it's got to prise apart the bits of wood to pull them out the way. The softer the wood, the easier that job should be, and since the blade is made of metal and the wood is a softer material, it shouldn't blunt or dull the blade as fast as when you go through hard stuff. And as anyone who cuts down trees and so on knows, if you hit bits of metal or bits of stone which have got into a tree, because that does happen from time to time, it instantly does for the blade, and it just damages the cutting edges. So I'm really surprised to hear that things like polystyrene would do that. The only thing I can think is with softer woods that might be wetter woods, maybe the moisture is doing something to the blade. With polystyrene, I am at a loss to explain that. So maybe a chainsawologist, if there is one listening, can tell us why that should make a difference. What's your theory, Simon?
That's fibrous nature of palm tree wood, for instance, and like microscopically, I think the polystyrene got something about it which is abrasive.
Well, certainly we can use plastic as an abrasive.
It's very stable and it slices off nice and neatly.
But I had the opposite experience, Simon, to be quite honest. I chopped up loads of oak the other day, and my chainsaw got duller sooner on the oak than it did on cheap and nasty bits of pine that I was chopping up. So I had the opposite experience. So I guess we have to put it to the test.
Well, they are lumberjacks and they are okay. If I want to bring in Monty Python, yeah. But I want to read an email that we received from Devon, and Devon was reflecting on our conversation that we had on Monday, and he says, "I'm a big fan of The Naked Scientist, so thank you so much for that." And he says, "Movies are becoming more and more accurate with attention to detail, but in Superman 1, Superman reversed time by he reversed time." By rotating and the rotation of the Earth, and he did this by flying around the Earth in the opposite direction. This of course can't happen. But one, What can reverse the rotation of the Earth? A meteor strike, and what would happen? And a two-part question, Chris. What is your most accurate science scene in a movie? I think that's a nice question.
First of all, on the kind of reversing time, yeah, we don't think that's going to be possible. It's certainly not possible by rotating a planet backwards. He's absolutely right that if something were to hit a planet, it could reverse its direction of rotation. And we think this has happened. There are planets in our own solar system that do rotate the wrong way or on their sides and so on. We think because of interactions with other impactors back in history. If you think about the physics, the reason that things spin in space and the reason that the sun spins, that the planets spin around the sun and so on, is because of a phenomenon called conservation of angular momentum. Everything is in motion in the universe, and so when the cloud of gas and dust came together that made our solar system in our universe, it was all moving. And there's nothing to stop it moving, so therefore the stuff has got to carry on moving even when it's stuck together. So the direction of travel is going to be the net movement direction of all of the pieces stuck together. So if you add all of the different velocities together for all the things, the bits of gas and dust that were moving around, the net direction is what's left over, and that's the direction everything moves and rotates in. So if you want something to rotate the other way, you've got to take away all of the momentum it's got in that direction. Momentum is mass times velocity, velocity being a direction as well as a scale. And you've got to put it in the opposite direction. So something's got to come in, hit your planet, which is turning in one direction, and have enough of an impact on it that it adds enough energy in the opposite direction to stop and then reverse the direction of travel of that object. If this were to happen, the impact would have to be so catastrophically big that it would wipe out the planet and basically disassemble it and then reassemble it from its component parts again. This has happened to our own planet back in history. If you look at the moon, our moon is disproportionately big compared to the size of the Earth. Other orbiting bodies like Mars has got Phobos and Deimos. They're very, very small moons of Mars. Why is Earth's moon so big? We think it's so big because Earth was hit by something about the size of Mars way back in Earth's history, and it ejected material into orbit around the Earth, which then coalesced to form this massive moon that we've got. But in the process of doing that, it would have melted the surface of the Earth, so there would be no prospect for life being left there, at least life as we know it. And therefore the whole concept of even if you could turn back time, hence we should have a clip of a famous song here, shouldn't we? If you could turn back time, there'd be no one there to see it or benefit from it or be the beneficiary of turning back time. Now, in terms of scientific accuracy in films, I'm an ardent Trekkie. I grew up loving Star Trek, and I've really been quite amazed at the insight and foresight of the creators of that series, because pretty much, with the exception of the warp drive and space time travel, pretty much everything that was envisaged by those people aboard the Enterprise back in the early days has come to pass. And we sat there glued to our screens watching this thinking, gosh, wouldn't it be nice if doors went and opened in front of you automatically, and if you could flip open this thing and then talk to somebody like you didn't have, like a phone, but there was no cable. And imagine being able to touch your badge and just talk to a computer and it would understand. And we all kind of rolled our eyes and thought it was such ardent science fiction. But it's all come to pass. People have got their smart speakers and so on now. It's all here. And for me, that remains one of the most amazing examples of things that you can dream about, but then see translate into reality in a lifetime.
Really appreciate that email. And how are you doing, Mike?
I'm good, thank you. And you?
Very good. Chris is listening.
Thanks, Chris. I've always wondered if you if you get the same nutritional value when you blend food like vegetables and fruits than you would if you ate it raw.
Oh, Mike, the answer is that you almost certainly would, in the sense that if you think about what your teeth do, they're like a liquidizer or a blender, and what your stomach is a muscular bag liquidizer. So by the time that stuff has got down into your small intestine, it's already been reduced to a soup, a bit like what comes out of a blender. And the only difference is going to be when you grind things up with a blender, you're probably making some of the calories more accessible a bit more quickly. But in the grand scheme of things, that's not making a huge amount of difference. You're also taking a bit of workload off your teeth, so you don't have to work so hard to chew the food up, and that will save you a bit of energy. So in the grand scheme of things, it's probably inconsequential, but there are some trivial differences. But in terms of nutritional access, just grinding things up like that, really all you're doing is short-circuiting what your teeth and stomach and small intestine does.
You happy, Mike?
Brilliant. Thank you.
Excellent. Wouldn't you use, from a caloric use point of view, sometimes the use of your jaw muscles and your teeth, would that be burning, calories as well? The process
right.
of mastication.
And that's sort of what I was alluding to, saying you're not going to have to chew the food up so much, so you will save a few calories there. Therefore, there is a slight nutritional benefit to making the liquidizer do the work for you. But then you've got to go to work to pay for the electricity, and that's a bit hit and miss, and sometimes, isn't it? So it really doesn't amount to a huge amount of difference. There's this old sort of saying that celery is this magic diet vegetable where you get more calories coming out of your body through trying to eat the blinking stuff than you actually derive from consuming it. I think you get some calories from anything that you eat, pretty much, unless it's plastic. I've eaten in some restaurants that seem to serve that stuff, and so as a result of taking food into your body, you will extract calories from it. You will have to masticate it and chew it up and chemically digest it. That takes energy, but hopefully you'll get something back from it by the digestive process.
There was a trick question I remember from high school biology. Where does digestion start? And we all think it starts in the stomach, but it starts in
your
the mouth with
yeah.
Salivary amylase. That's something that I somehow remember from high school biology. Salivary amylase starts digesting food already when it's in your mouth and you had that first bite. But let's go to another question on the voice note line.
Hello from Patrick in Seabrook. I've got a question for the naked scientist. Do people sneeze in their sleep? In all of my years, I've never heard anyone sneeze in their sleep, and I can't remember sneezing in my sleep, and I wondered, is it a thing?
That's one of those questions of like, now that you mention it, I also don't think I've experienced someone sneeze during their sleep.
I'm disappointed in you, Lester. You should have said, that's a question not to be sneezed at, or that's a question not to be sniffed at. The answer is I don't know 100%, but I did 2 nights ago sneeze in the night, and I woke up to do it. I woke up because something was making my nose tickle, probably pollen or dust or something, the dog being on my bed at some point because he keeps going on there, and it made me wake up with a tickly nose, and I sneezed violently twice. I sneezed into the duvet so I wouldn't wake up my wife. Did that count as sneezing in my sleep because I woke up to do it? I'm not sure. I wouldn't know if I'd sneezed in my sleep because I would have been asleep and wouldn't have noticed, so I only remember doing that because it woke me up to do it. I've never heard anybody sneeze in their sleep, but then I haven't slept with lots and lots of people over my lifetime and done an analysis of staying awake all night to see if they sneeze in their sleep. So I don't know for sure. When we go to sleep, our physiology does change a lot. As in, we turn off lots of our sensory systems so that we go into a state of deep relaxation, at least for most of the night. And so it could be that some of the reactions and reflexes that happen more readily during the day are more suppressed at night. We know, for instance, our saliva flow dries up, our tear flow dries up, lots of things like that. So it may well be that the stimulus for sneezing has to be that much higher to make it happen at night. But you'd think the reason for sneezing is to safeguard clear passage through your airway, and that remains relevant whether it's night or day, sleep or awake. So you'd think, in the grand scheme of things, that it would not make evolutionary sense to suppress sneezing when you're sleeping. So I would speculate that it does happen, but because we only sneeze relatively infrequently, and because we breathe less at night, because we slow down our breathing, you probably get less irritation to your airways at night, and you probably wake up to sneeze for the reasons I've outlined most of the time. So it can happen, but we just don't witness it very often. And if it happens to us when we're asleep, we don't notice. That would be my interpretation.
Anton in Fisher, good morning.
Hi there, folks. Good morning. It's a mathematical question. I don't know if you've heard that. Just for example, the 3 guys go out for dinner and they go Dutch. And for example, the bill comes to 30 Rand. The waitress goes and cashes up, but the bill only came to 25. She can't divide 3 into 5, 3 out of 5. So She gives them each 1 rand back. She puts 2 rand in her pocket. So in effect, they've each paid 9 rand. 9 threes, 27, the 2 rand. What happened to the rand? I've never figured that.
I'm someone who literally got an H for maths in matric. I'm literally.
It's one of these. It's one of these trick questions where it's the kind of economics that Jacob Zuma's proud of. I don't propose to solve this on the radio, but if you write it down, you can see that it's a trick, and in fact, somebody's made a bit of money where somebody hasn't. So it's just a trick of words. It's not that magic money has turned up. We thought we had a magic money tree when COVID came along and everyone started borrowing cash hand over fist, but no, it is just a mathematical trick. But I'd need to write it down to make sure I've understood the question correctly and see it. But I've been subjected to this before, not on the radio, in real life, and I know it's a trick, but I'd need to write it down and then explain it. Why don't you post it to me, email it to me, and then I'll disentangle it for you next week.
I'd appreciate that. Thank you so much, Anton. I'm going to throw some more sneezing questions at you, Chris. It seems to be a thread now, something that has tickled. The question is, where does the kinetic energy of a stifled sneeze go? And I sometimes stifling a sneeze could actually hurt my body a little bit more. There's a lot of energy release when you go, ha, 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 chow. But sometimes when you hold it back and you go, sometimes it's a greater impact on the body. Where does that energy go to?
Well, first of all, what happens when we sneeze, and why do we sneeze? We sneeze to clear out airways, and it's usually a reflex and a reaction in response to airway irritation, especially the upper parts of the airway in your nose. And the way that you achieve a sneeze is that you hold your vocal cords closed, you squeeze all your muscles around your chest and your intercostal muscles, push up your diaphragm to raise the pressure inside your chest cavity, and then you release the air through your vocal cords all at one go, achoo. And the same with a cough, but it's a slightly different way of creating the reaction. But it's basically a big release of energy all at once. If you stifle the sneeze, you basically dissipate the energy into the elastic tissues of your body. And as you've said, you can sometimes feel pain in some places. My daughter was complaining to me the other day that she had bellyache when she moved in a certain direction and realised that she'd been playing a lot of sport and pulled a muscle. And when she was sneezing or coughing, it was transferring the pressure to the abdomen, which is what basically happens when you breathe in, you push your diaphragm down. So if you sort of take a deep breath in to cough or sneeze, you will increase your intra-abdominal pressure, and that stretches everything. So when you don't let the energy outwards very, very much in an acoustic way with the sneeze, you keep the energy in, you basically transfer it into the elastic tissues of your body, stretch everything and make everything move a bit, and you dissipate the energy within your own body.
Shamil Pinelands, good morning. How are you?
Hi, good morning, Lester. I'm good. Yourself?
Very good, very good. What's your question?
Okay, I've got something that troubles me all the time. So I'm a sweet tooth, right? So I want to know, when I have a piece of cake, a piece of chocolate cake, and I eat that chocolate cake, and then I drink my coffee or tea afterwards, why is the coffee and tea bitter?
Thanks so much, Chris.
The reason for this is that taste and flavour perception is all relative. The way the nervous system works is it doesn't deal in absolutes. If you put your hand in cold water, you'll say it's cold. But if you then put your hand in even colder water, you'll say, wow, that's cold. But put your hand back in the first water and it now feels hot. And the reason is the nervous system is much more interested in change and how things are changing relative to your status quo than in absolute levels, like if you had a thermometer in that bowl of water. And the reason for that is it's change that matters to us. If you're sleeping and suddenly smoke appears, you need to know not about the temperature of the room, not about actually what the oxygen concentration is and so on. You need to know that suddenly there's smoke there and there wasn't smoke there. You need to know that the smell of smoke is getting worse, because if it's staying the same and it's always there, doesn't need to bother you. But if it's getting worse and therefore there might be a fire that's going to engulf your home, you need to get out. So the nervous system works very much on relatives and changes, and it has a process called adaptation. And as we experience more of something, we adapt our nerve response, we turn it down to desensitize it to that response. We get used to it. A really good example of this, there's a bad smell in the room from whatever source. When you first go into that room, you think, gosh, it stinks in here. After a few minutes, you stop noticing it because you have adapted to that smell. Flavour and taste, exactly the same. when you have something very strongly flavoured in your mouth, you adapt down the sensitivity of all of your taste and smell receptors to that particular spectrum or constellation of tastes and odours. So when you then put in a new flavour, it's seeing a nerve repertoire of activity which is now retuned in response to what you had in your mouth before. And if that thing that you had in your mouth before was intensely sweet, you will desensitize your sweet system a bit. So when you put something in that's of normal sweetness, your body says, this is really, really bitter, because the sweetness is now not being registered as strongly as the other compounds which are there, and the bitter tasting ones that would normally be there alongside the sweet, but you wouldn't notice them so much because the sweet would compensate. Now you've detuned your sweetness detection, you really notice the other flavours. And this is the art of clever cooking, or what they're dubbing molecular gastronomy. It's all about understanding the different profiles of tastes and flavours and how you mix them together to complement and contrast each other to use this effect. And people who are very experienced chefs or people who are wine connoisseurs know this really well. They know what wine to put with what's on the plate in order to get the best out of both and use this very effect.
Is it similar to why I know some people who go swimming in the rain? You know, Cape Town water is very cold, but they say that if they swim when it's a little misty, maybe even a little bit of rain, the water actually feels a little bit warmer to the touch, or not as cold as it would be on a very, very hot summer's day in Cape Town with a very, very cold Atlantic Ocean. Is that also a form of adaptation?
I think that's right. You're outside, it's cold outside, and so the difference between what you're already feeling and the cold water, and I've swum off Cape Town, believe me, I know all about that, what you're talking about, that cold sea, it's freezing. But when you get in there, you are contrasting the outside temperature that was colder with the cold water, and the difference is not so stark. When you are boiling hot and sweaty, it's been a really hot, strikingly hot sunny day, and then you get in freezing cold water, you really, really notice, and it's exactly that reason.
We have an explanation for the bull problem. It's on a voice note. Let's have a listen. Johannes?
The 30 Rand, 5 Rand back, everyone gets 1 Rand, she keeps 2. So you only spent 9 Rand, but where did the extra Rand go? You didn't only spend 9 Rand because the 3 of you also contributed towards the 2 Rand that she kept. So actually you spent 9 Rand plus 2 Rand divided by 3, and I'm driving at the moment, so that's like, I don't know, can't do the maths, just shy of 70 cents each. So you actually spent 9 Rand and 70 cents each, not 9 Rand, and that's where the extra money went.
Does that solve it, Chris?
Oh yeah, absolutely. But I didn't have time to write it down quickly enough in order to decode it. But thank you very much. And yes, she's absolutely right. It's a trick.
Look, they lost me when they said, "Here's a mathematics problem," and it's not my faculty. But Chris Smith, thank you so much again. Looking forward to next week. I hope you stay well. You're a valuable member of this team on a Friday at 9:30. Thanks so much. Enjoy your weekend, sir.
Enjoy your weekend, Lester. See you soon, everybody. Have a good one. Bye-bye.
Bye-bye.